Hello. So in this video, we will make a calibration of this simple network using the program Escape. So the network consists of these uh, four paths, and it has five nodes. You see here the uh, numbers in red are the number code of some nodes, 0, 1, and 2. There's two additional nodes, 3 and 4, that it's destination nodes. So pedestrian will want to end up here during the evacuation simulations. And then ID code of the links are in blue here. So this is the link 0, 1, 2, and 3. The coordinates of each node is also shown here. So to run the software, we will need basically three files inputs. One of the file input is called nodes.csv. So the file is in CSV format. Okay, so it has this configuration. This is the format. It has five columns. Okay, the first column is an ID number, so it's just from 1 to 4 because we have four nodes. And then the second and third column are the x coordinate and the y coordinate. Then the fourth column, it's a binary number, or 0 or 1. 0 means the node it's an ordinary node, and 1 means the node is a destination node. So you see here that the node 3 and node 4 has a destination node because the variable is 1 here. And from the node 0, 1, and 2, 0, 1, and 2, the fourth column number is 0. Okay, we have a fifth column which has number 1 in all the nodes. So this is just for an experimentation. So please, for this time, just ignore this number. But it must have, okay, these fifth columns. Well, we also have the input file link CSV, which contains the information of the links. Okay, so we have here four links with ID 0, 1, 2, and 3. Those over here. Okay, so the second and third column represents the nodes ID of the ends of every path, every link. For example, in link 0, the nodes at its ends is 0 and 1. So you can see here 0 and 1. Another example, link number 3, the nodes on its ends is 2 and 4. So let's see here, link 3, the nodes ID are 2 and 4. Yeah. So the fourth column represents the length of the links. So you see here 20, 28, and 15. So it means this link's length is 20. This one is 20. The link 2 is 8 meters and the link 3 is 15 meters. Okay. Then the last column, the fifth column that you see here 2 in all cases is the width of the path. So we will need this number to compute the density of pedestrians during the evacuation. Okay, so with these two files we can model the network in which the pedestrians will evacuate. But we will need also a third file that it's called actually population.csv, and you have here a small example of that file. In this file, we have five columns. Basically, every row here represents a pedestrian that will start the evacuation. Here, uh, every file have five columns. Every row has five columns. Okay. So far, the first fourth columns are variables that are in development currently. So you just need to ignore this for the first fourth columns. Please focus on the last column that it's 0 here. The last column is the number of the node ID from which a pedestrian will start the evacuation. Okay, so in this small example, all the pedestrians, that it's about 3,350, will start the evacuation from the node 0. So from this end. Okay, all of them will start from here. Okay, so let's see now the how we can make the simulation of this network. So I assume you already cloned the software from the GitHub repository. Okay, so we have to go to the folder tutorials. So I prepare this new folder called, well, this is in Spanish. This is example 01. And inside this folder, we have the minimum folder and files that we need to run the software. So this is the 3 files that I just mentioned, described to you. So we can open. This is the file of the links. It's over here already. This is the file of the nodes. And we can also open population. So you see here, this is the population, the file population. Okay. Then to calibrate the uh, evacuation guidance system, we will need an additional file with the setting parameters, which the name of that folder is control dict, D-I-C-T, which is located in the folder called system. Okay, you must have this folder called system, and inside here you have to have this file. And we can open the file. I have this configuration. So for example, for population files, we have to specify the file of the population, the type of the process we are doing. We will calibrate the network. So this variable must have calibration here. Then this is another parameter called end time. We have here 1200. This is 1200 seconds. So it means that every simulation, evacuation simulation, will consist of 1200 seconds from which the pedestrian will start evacuating. Okay. So this is the mean Riley, 420. So this is if I'm not wrong, this is the average of the Riley distribution for the starting time of the distribution of the starting time of the pedestrians. Okay. And over here we have another variable. The name of this variable is number simulation, which is 150. It means that for the calibration, we will use 150 simulations. Okay, so the way we have to do to run the calibration, we have to go to the main folder of the project, which is ejemplo 01. Then we will open a terminal. Okay, let's confirm. Okay, we are here. Then we have to run if we already compiled, there's a sarsa file, which is in the folder bin. Okay, so we have to go to the folder bin. And over there, run the file sarsa. Okay, you can put the path of this sarsa compile file in your path if you want. That's if you want, you just need to run like this. Just go into the bin folder and run over there sarsa, and the simulation will start processing. Okay, so if you remember, we set 150 simulations, so you can see here the number of simulation and a small report like the survived pedestrians and the duration of each simulation. All right, so the calibrations is already finished. Then we can check the results in the folder. You will see that in the folder, three new folders were created. Okay, but let's open first the folder called state matrices, which was empty at the beginning, and now uh, they have all the files that was created during the simulations. So every file represents what the system learned in each simulation. So this is from the first simulation, second simulations, and so on. So the last file is over here, 150. So if we open this one, this is the information that the guidance system uses to suggest path for the pedestrians. Okay, so we will see the results on the next video.